Then the second method is DENCLUE, which is a short form of density based clustering. We have selected an unvisited point. Up next, we are supposed to find all the points that fall within the epsilon distance, and each cell will store the statistical information like mean, value, count as well as the variance values by taking the density thresholds and a number of grids as input parameters. Hello everyone, I welcome you all to the second session of Unit 4. Unit 4 is all about clustering. Yes, we have already completed one more session in this unit. I request you all to go back and check that video too. Over here, my name is Deepa Kutnikar. I'm working as an assistant professor under Department of Computer Science, Vidhyaashram, Temple of Excellence, Mysuru. Yes, in our previous session, that's in session 1, we have discussed the introduction of clustering analysis, like what is cluster analysis, then followed by we did discuss the types of cluster analysis, where we have completed 2 types of cluster analysis. First one is partitioning method and second one is the hierarchical method. So we have completed these things in our previous session. Alright, let's see the agenda of today's session. In today's session, we will be discussing rest 2 of the cluster analysis methods, that is grid-based method, density-based method, then how to evaluate the cluster analysis, then the distance measuring in algorithmic methods, then followed by types of linkage in cluster. So this is the agenda of today's session. Let's begin our session. The density-based approach, it refers to the unsupervised ML approaches that finds the discrete clusters in the data set. So over here, let's see the representation of a density-based clustering. So here the clustering is available. Here the clustering is available. And inside that cluster, we can see the unsupervised ML approaches that corresponds to the discrete cluster in the data set. So we can observe each and every cluster are different. No cluster is same as one, isn't it? And we can observe the discrete values inside the cluster. Yes, this is a density-based clustering. And we have 2 of the methods under this density-based clustering, where the first one is dbScan, which is a short form of density-based spatial clustering of applications with noise. Then the second method is DENCLUE, which is a short form of density-based clustering. So these are the 2 methods. Through this, we can get a density-based clusters. Okay, let's understand this dbScan, which is nothing but density-based spatial clustering of applications with noise. So the name itself saying that this is capable of identifying the noise or the outliers. Okay, that's the initial thing. Through the name that we can understand, correct? Next, we can say that the dbScan forms the clusters based on the areas of high density data points. Alright, so the figure over here, this shows a representation of an exact dbScan. So over here, we can observe there are 3 different clusters, and out of that cluster, we have a single data, that's a central data point, which is considered as a core. Alright, and the radius is considered as the epsilon. Then further, we can see a simple border as well as the noise which this dbScan is identified. Alright, so now let's understand the key parameters that is considered while representing this dbScan. The first one is none other than this radius, that is epsilon, which gives us an exact radius of the neighborhood. Alright, the next parameter is min points, which specifies the minimum number of points required to form a dense region. Alright, up next, let's understand the points. Like we have mentioned few points here, the border point, noise point, correct? Then the core point. So what are these points? So let's understand that, starting with a core point. We can say that a point can be called as a core point only when it has minimum points within the epsilon. Up next, the second point is a border point. The border point has a fewer points than the minimum points, but it lies within the epsilon of a core point. So you can observe here the border point, it lies within the epsilon of a core point. So within this radius, the border point is been situated. Up next, the third point is the noise point. The noise point, we can say it will not be within the core point or not inside or within the border point. So that will be completely considered as a noise. So these are the three different types of points. Okay, now let's see an exact algorithmic steps that is been followed under the DB scan. The first step is to select an unvisited point. Okay, we have selected an unvisited point. Up next, we are supposed to find all the points that fall within the epsilon distance. Yes, within the epsilon's distance. Up next, we are supposed to verify that a count value is it greater than or equal to minimum points, which is responsible to form a cluster. Okay, up next, it expands the cluster by recursively adding the density reachable points. So these are the steps that we follow with respect to the DB scan. Up next, let's see what are the advantages of this method as well as the disadvantages. So starting with advantage, yes, absolutely, we can say that this is capable of handling the noise efficiently, followed by it detects the arbitrary shaped clusters very easily. So these are very important advantages. Up next, let's move with the disadvantage. Thus, we know that the values that we consider is a epsilon as well as minimum points. As the complete algorithm is dependent on it, we can say that this DB scan is sensitive to epsilon as well as minimum points in the cluster, and the performance also varies. So it gives a poor performance on varying densities. So this is the disadvantage. Up next, let's move with the next method, that's DENCLUE, which is a full form of density-based clustering. This DENCLUE uses the mathematical density functions instead of the distance thresholds. The core concepts of DENCLUE includes the influence function, which gives a measure of influence of a data point. The next concept is a density function, which is responsible to provide the sum of influence functions. Okay, up next, the third concept is the density attractors. These attractors will provide the local maxima of densities. Up next, let's understand the advantage and disadvantage. The main advantage of this is this: the DENCLUE will efficiently handle the large data set. So that's our first advantage. Next, it provides a strong mathematical foundation for any of the data cluster that we consider. So these are the two main advantages. Up next, let's head with disadvantage, or we can also call it as limitation. The main limitation is the implementation is complex. The next limitation is it requires the parameter tuning. Yes, so this forms a limitation for DENCLUE. Up next, let's head with the next type of cluster analyzing method, that is none other than grid-based method. The grid-based method uses a multi-resolution grid data structures. It quantizes the object areas into a finite number of cells that forms a grid structure on which all of the operations of clusterings will happen. So under this grid-based also we have two different methods. The first one is STING, which is none other than statistical information grid, and the second type is the CLUE, which is nothing but clustering in quest. Okay, this is a grid-based methods representation. Let's understand the STING type of clustering technique now. In STING, the data set is recursively divided in a hierarchical manner, and after the data set, each cell is divided into a complete different number of cells. And once the cells is been designed, then the statistical measures of that cell are collected. So this will help us in answering the query as quick as possible. So that's the advantage of string. Now let's understand how exactly a string will work. So initially, it selects an initial layer in the hierarchical structure to start the query processing. So that's the first thing. Next step, it estimates the probability range for each cell, indicating its relevance to the query. The next step is the labeling of each cell will happen as relevant or non-relevant, which is considered based on the probability of interval that we consider. Up next, we need to verify whether the current layer is exactly the lowest layer in the hierarchy or what. So we will be verifying it. Up next, we are supposed to move one level down the hierarchy and repeat the complete process for the cells marked as relevant. So this is a complete process of working of string. So out here we have a real-time example where initially we need to verify whether the query requirements are satisfied at the current level or what. Okay, up next, we will retrieve the process data from relevant cells to generate the final query result. It identifies and returns the contiguous regions of relevant cells that satisfies the query conditions, and at last it terminates the algorithm after producing the result. Correct, right? It has to be terminated. Yes, it will be done. Alright, now now let's move forward and understand few of the characteristics of string. The query processing under the string uses the pre-computed statistical values, and each cell will store the statistical informations like mean, value, count, as well as the variance values. So that's the characteristics. Let's move ahead with the advantages. The main advantage of string that we can consider is the processing speed. So it is very fast. It is independent of number of data points. So this is a second advantage. Let's move forward with understanding the limitation of string. The accuracy of the string is completely dependent on the grid structure. So this forms the complete disadvantage or limitation with respect to string. Okay, Cluke. Up next, let's understand the next type of grid-based method, that is none other than Cluke. We can say that Cluke is a subspace clustering algorithm where it is responsible to find the cluster by taking the density thresholds and a number of grids has input parameters. It is specially designed to handle the data set with the large number of dimensions. So that's Cluke. The advantage of Cluke involves its effectiveness for high dimensional data. Correct, right? We know that. Okay, let's move ahead with understanding the limitation of the same Cluke. The main limitation is the grid size selection itself is the critical task. So this forms a limitation. Alright, now let's understand the working of Cluke algorithm. This is very important. So let's understand this. It all starts with the data space. So initially the data space is partitioned into grids by dividing each dimension into equal size intervals called units. So initially we have to create a unit, or we have to create the units. Next, we are supposed to identify the complete dense units in that whole created units. Okay, we will pick the dense units. So how to pick that dense units? It's by comparing the number of data points in each unit with a predefined density threshold. Thus, we can say that the algorithm first finds the dense units in one-dimensional subspaces independently. Further, the dense units are combined to discover the next dense units in the higher dimensional subspaces using the a priori property. Next, this process will continue taking iterations until no more dense units can be found in that higher dimensions. Further, the common dense units are grouped together to form a cluster in each dense space. So, clusters are formed in each dense spaces or subspaces. Thus, we can say that the largest connected sets of dense units are selected as the meaningful clusters. So, we will be forming a meaningful clusters out of the clusters that are formed. Further, a minimal description of each cluster is generated to compactly represent the discovered subspace clusters. So this is a complete working of Kluge algorithm. Now let's see how the distance are measured in algorithmic methods. So there are few common distance metrics with respect to algorithms. So let's consider that. The first is Euclidean distance. So this is very important and crucial one when we speak with respect to clusters as well as with respect to distance measures. This is responsible to calculate the straight line distance between the 2 points, and the representation is in the form of square root of summation of xi minus yi whole square. And we can say that this Euclidean distance is a best fit for a continuous numerical data, though it has sensitivity, though it is sensitive to outliers. The next distance measure that we can consider is none other than Manhattan distance, which is called as taxi cab distance in simple words. So this is responsible for calculating the exact distance between the coordinates. The representation is mod of xi minus yi, and it is completely ideal for high dimensional data or grids, and it is less sensitive to outliers. The next distance metric is none other than the Minkowski distance. It gives a generalization that encompasses both Euclidean and the Manhattan distances, and it is represented as summation of mod of xi minus yi to the mod power p whole power 1 by p. So this gives one of a distance metric with respect to various algorithms. The next topic is types of linkages of clustering. So we have various types of linkages, so we will be studying this, starting with single linkage. So over here we can see the representation of single linkage. We have two clusters, and in between that, if I form a single link, then I can call it as a single linkage. Moreover, the single linkage can be defined as the distance between two clusters has the minimum distance between any single pair of points, often leading to long chain of clusters. Okay, up next type of linkage is a complete linkage. This measures the distance using the maximum gap between the most distant member of two clusters to create compact, tightly bound groups. So this is a tightly bound group, that is a complete linkage. All right. The next type of linkage is the average linkage. It initially calculates the mean distance between all the possible pairs of points between the two clusters, offering a balanced compromise between single and complete methods. Thus, over here we can see the average linkage. Yes. The next type of linkage is none other than a centroid linkage. It determines the distance based on the coordinates of the geometric center of each cluster rather than individual data points. Yes, the centroid linkage is over here. So these are the four different linkages that is possible with respect to clustering. The next topic is evaluation of clustering. Okay, we have learned like what is a cluster, then followed by how to analyze those clusters and what are the different types. Under the type, what are the different methods. So we have already learned all these things. Up next, the only thing that is remaining with respect to this unit is evaluation. Yes, once a cluster is formed, it has to be evaluated for its efficiency, correct? So that's the thing that we discuss in the slide, which is nothing but evaluation of clustering. This is responsible for accessing the quality of unsupervised groups using the internal metrics like cohesion or separations, even when the labels are unknown or the external metrics are unknown. So we have the external metrics which says that comparing to the ground truth. So these are the basic internal metrics, that is none other than cohesion and a separation that we consider with any of the evaluations. Further, we can say that the key clustering evaluation techniques are: the first one, internal evaluation, which includes no ground truth, but the next one is external evaluation, which includes the ground truth, and the ground truth will be available for the evaluations. So this is how we can internally evaluate as well as externally evaluate with just considering the ground truth and by leaving the ground truth. So this was all about evaluation, and yes, all the very best for your exams. Score well, do very well, and see you up in the next semester. Until then, thank you.